To start with the STAAD.Pro analysis, we need to click onto this icon. Double clicking on this icon, which will lead to starting of the STAAD.Pro analysis software. Now we need to look into new project. Now we need to click on the new project, then click on the space, then we need to click here we need to create a new file, which is earthquake earthquake analysis lab. Then we need to check the location. After that, the units should be meters and kilonewton. Then click next. Then the next window should be add beam, and click next. After this one, uh, we need to wait for a few seconds. Then the window will appear in the snap node beam. So we need to close this window. After this one, we need to move into geometry, run structure wizard. In the structure wizard, we need to go into drop down menu. In this one, by clicking on the drop down menu, there will be so many other modules will be there. For this example, we are going to take frame model. Clicking on that frame model, there are so many other frame models are there. For this experiment, we are going to take a bay frame. By clicking on that bay frame, we are going to get the dimensions of the building. We need to type 10, 15, 10, 4, 5, 4. We need to take it. Then we need to click apply. This is the model of the building. You can see the plan 3D and the model. So we need to click on this one. Then to import this model into our STAAD analysis, we need to click close this one. This would you like to transfer the image? Yes, we need to transfer this. And near the coordinate 0, 0, and we can click OK. So we have now imported this model. After importing this model, we are going to create a tower like structure above this one. So we need to go to the side view. Then we need to select this beam cursor, then select these beams, then new view, click OK. Then we need to go to the 3D view. This is the only models are left. After this, we need to go to plan. Then we need to select beam cursor. Then we need to select only these four these beams. Total it will be four, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12 beams. 12 beams will be there. So we'll go into 3D, then go to geometry, translation repeat, Y direction. Then we need to create number of steps 5 and height is 3. Spacing between them is 3. Link the steps and click OK. This is the model we are creating. Then we need to see the whole model. This is the whole model. Then we need to go to side view again. By selecting the beam cursor, we are going to select these. Then right click on that one. We will get a new view. Click OK. Then go to the 3D view. So select this beam and a node cursor. By selecting the node cursor, we are going to select this one. Right click, copy, right click, paste the node. It should be in the y direction, positive y direction in 3 meters. So click OK. So this is the single node which is having a height about 3 meter above the all other nodes. So from there we need to select this beam, add beams. So we need to connect all the beams to this one. Then from here to here, from here to here, this is the crown of the building. So this is the crown of the building. By collecting all the nodes, then so this is the way we are going to create the crown of the building. You can see here. Then we are going to make a whole structure. So this is the completed building. Then we'll click escape. Then again we'll click and unselect all the selected nodes and beams. Now we are going to create the neighboring building which is adjacent building to these frames. So for that we need to go to side view. Then again we'll go back to side view in X direction. We are going to select side view which is in the top view. This is the top view. This is the side view. So in the Z direction, this should come in Z direction. Then we are going to select these frames like this. Frames. Then if you see in 3D, it will look like this one. Then we need to go to geometry, translation repeat in Z direction. Then we are going to make the number of steps will be uh, 4 and distance between them will be 2.5. 2.5 link steps. Click OK. So this is the created model. This is a created model we can see here. Then clicking on this one, this is the completed model, 3D model, and we can see all this model. So after creating this model, now we need to create supports, properties and loads on the structure, and we need to analyze the structure. So for this one we need to go to general, properties, define rectangle 0.5 4, which is 400 mm, 0.4, 0.4, click add. Then we'll have a column 0.6, 0.6, click add. We'll close that one. Now we need to create a 0.4 size beam, even the inclined beams also. So for this reason, we need to select those inclined beam as well as horizontal in x and y direction. So for that, we need to select beams parallel to y, then select beams by inverse the beam selection. Then it will create the all the other beams. All the other beams are there. So click assign. Yes. Ah. Now from here we can see that bottom beams are also present. We need to delete that one. So uh, what we can do is just go to the side view in the Z direction. We are going to select these beams, then delete. That's all. Then now we need to select the columns. So give a properties of 600 mm square size columns. So we'll select on this one, geometry, select beams parallel to y direction. Then it's a selected beam. Click assign. Yes. After this, we can see that 0.4 is the size of the beam, 0.6 mm square section is the properties of the column. After providing this one, we can check whether we have missed anything. So go to the select by missing attribute, by missing property. So there is no missing, no entity is missing property is found. Click OK. So we have assigned the material property correctly. Next one, we need to provide a support. For that reason, go to the side view in the Z direction, then general, support, create. We are going to create a two types of supports. One is fixed and one is pinned. So first one is fixed, click add. Next again create pinned support, click add. So we'll select on the first fixed support, click select up to the big structure, and if you see from 3D it will look like this. Click selected nodes, assign. So this is the way we are going to assign these properties. After that, we are going to have a uh, view in side view. Go back to side view, then in the Z direction, then we'll click on the support, then we deselect all the other support, then we'll click select those end of the support nodes, then we'll assign this hinged support, click assign. Yes, by doing that one we are going to get this kind of support. One is fixed, another one is hinged support. So after this one we need to create a earthquake loads, dead load, live load, and we need to create a combinations of Indian code specified combinations. So for that one we need to go to general, loads and definition, we need to create definition. Here seismic definition, click add, then we have a specific parameter, seismic parameter. UBC code is not uh, Indian code, so we need to select the Indian IS 1893 2005. Then in this one we need to select these parameters. So for the zone 5 we have 0.36 value. Then a response factor, we have a special for the special re, moment resisting frame, we have the response reduction factor, it is 5. Then the importance factor will be 1. Our building is on soft soil, so value is 3. Hard soil is 1, medium soil is 2, and soft soil is 3. So our building is on soft soil, so 3. Type of the structure, it is a RC structure, so hence it is the value 1. Damping value ratio is 0.05, that means 5%. Click add. Next one, we need to create a sulfate factor, so we are clicking add that one. Then we are going to add uh, member load. Member load, that is the weight of the beams. So for this one we are going to select uniformly distributed load. For this one member weight will be, we need to open the calculator. The size of the beam is 0.4 into 0.4 multiplied by unit weight of concrete 25. Click OK. This is a 4 kilonewton per meter in the negative y direction, negative gravity direction. So value should be -4. Click add. Then we will have a floor load, that is the weight of the slab. So for that one we need to open the calculator. We are going to assume 200 slab. So for this one we need to clear this one. 0.2 into 1 into 25, that is equal to 5 kilonewton per meter. So value is -5, -5. So the range will be 3 to 3 to 3 to 30 meters. 3 to 30 meters. Click add. We need to close this one. Here again we need to assign this value to the members. So for this we need to select beams parallel to y, then inverse that selection, beams parallel to inverse beam selection, then assign these properties. Select the beam and assign. Now the beams properties are assigned, the load values are assigned. So now we need to create a load cases. For this load cases we need to click on the load cases. We need to click add. Now we need to create earthquake load only. So seismic load first one. So we have EQ plus x direction. We need to click add. Next one, EQ earthquake load in the negative x direction. EQ negative x direction. negative x direction, we need to click add, then EQ earthquake load in the positive positive z direction. Z direction, click add. Next one, EQ negative Z direction. Z direction, negative Z direction. We need to click add that one. After that one, we need to create a dead load. We need to create a dead load DL. Click add. Next, we will create a live load, that is LL. Click add. We have created a 6 load cases, and now we need to go into auto load combination generation. Click on that one, select Indian code. Next, generate load combination. These are the generated load total 27 combinations are generated. Click add. So after this one, we need to close this one. Then we have to go back to the load cases, 6 load cases. Inside that one, we need to create, put some load values. Here these loads are empty. We have created only load cases. Inside that one, we need to create a load. So click on that one, positive X, click save, save it. Then click on the X, positive X, click add. Go to the seismic load, X direction, factor positive X, correct, click add, close. Here we can see that load. Then again click on to the earthquake load, add, then again seismic, but this time it is minus X direction, click add, close. Next value is earthquake load in Z direction, click add. We need to go to seismic loads, Z direction, positive Z direction, add, close. Again click on the earthquake load negative direction, click on the add, go to the seismic load, then Z direction minus 1, click add, close. Now we need to add the load, dead load, add. We need to have the minus floor load is there, floor load. We need to have value of -2, range is 3 to 30 meters, 3 to 30 meters. Click add, close it. If you click on that one, it will show the dead load. Then last one is live load. Click on the live load, click add. We are going to put another 5 kilonewton of floor load, -5. These are all vertical loads, 3 to 30, 3 to 30, add and close. So click on that one, we will get this type of load. After this one, we need to click on command analysis, perform analysis, click OK, then command post analysis, analysis result, OK, then analyze, run analysis, yes. We need to check for any errors are there before going to design. So we'll stay in the uh, stay in the modeling mode only. Let's without error, any error, we are completed this analysis. Click done. After completing the error-free analysis and staying in the model, we need to go for design of this watchtower. After doing this one, what we have to do is go to design, concrete design, then go to here we need after selecting this concrete design we need to change the code. So we need to select IS456. Then after selecting we need to select some parameters. These are the parameter we need to click here. We need to select very only two parameters. One is FC double click, FY main double click. Then we need to select click OK. After that we need to define the parameters. Type 30,000 that is 30 MPa. Click add. Then FY may 550,000. Click add. Then we need to close this one. After that we need to assign these properties. FC main, click on that one, click assign to view, then click on the FI main, assign to view, assign. These are the parameters which is same for beams and columns. That's why we are assigning to view. Then the last parameter was design beams, columns and calculate quantity. So we need to click on to the command, then beam, we need to add, then design of the column, click add, then take off quantity of steels and concrete will be calculated. So click add. So we need to close this one. Concrete takeoff will be automatically added to the whole structure. Now we need to design beams and columns are there. We need to assign to the specified members. So after that one, to assign that one, we need to click on to this window, click on to the beam, select beams parallel to Y, then select beams by inverse selection, then assign these to selected beams. It comes to the automatically comes to that one. Yes. After that one, select design column, go to the select beams parallel to Y, assign to selected beams. After this one design part is over. Now we go directly to analyze, run analysis, click yes. The program will run once again with zero errors. So now it is starting concrete design. So after that one, the analysis is completed with zero error, one warning. So we'll go to the see the output file first. Then click done. Here we can see that design part also is taken care. All this analysis part is there. Here beam design, we can see that beam design, each summary of the reinforcement designs of the beams and frames are assigned. So beam design, everything is there. So in the end we have a quantity of steel bars required also is calculated in the end. So this is the concrete design part. Now we'll close this one. Now we'll go back to our mode post processing. We don't want these 6 load cases, we want combinations only. We move this one, click OK. Now we can see that printing any displacement in the x y direction for the combinations only. We can see that values. So first one, node displacement. So here displacement, we can see how much it has displaced due to any other loads are there. We can change this one to any other form. So we can see the displacement values here also. How much it has displaced? It is 0.014 mm. Now we can see the nodes reaction force. So we can see the reaction forces. It has shown for all the supports. So this is for hinged support. Now this is for fixed support. So this is the way we can see the bending moment, shear, vertical forces, horizontal forces. Here bending moment is zero because of hinged support. So this is the one we can see that. After that one we'll go to beam forces. This is the bending moment diagram. Here we can change the any type of load. So forces, the forces. So we'll change the graph. We can see all these values. See here we can see the earthquake loads also, horizontal load. We can see the combinations of load. It will take some time. If you click on this one, we'll get a value. It is a huge file. Due to this, it will take some time. If you click on the combination, it will come slowly. Now x direction, positive x direction, negative x direction, positive z direction earthquake load, negative z direction earthquake load. Now dead load, then live loads, and we can click on the any type of load which is having a combinations of dead load plus the earthquake load plus live load, like that. So total 27 combinations are there. For this one we can see the bending moment shear force diagram, and whichever maximum value is there we can see by envelope value some of the maximum values. So we can design the beam and columns for this one. After this one can select any one column, double click on that one. We can see the concrete designs also. Each member concrete design, deflection, shear force, then properties, any properties, length, so everything we can see. So this is the one. We can double click on any other columns also. We are going to get a concrete design. How many numbers of bars are there? Everything we are going to get this one. Then we are going to select any one horizontal beam like this. This is the concrete beam design. That was a column design, this was a beam design. Here we can see the beams at the starting point, middle point, and then the end point. What are the reinforcement requirements? So we can see that one, and we'll close this. After this, we can see the bending moment diagram. For bending moment diagram, what we are going to do is go to the top view, select any one frame. Select any one frame, because bending moment we can't see. This building is huge, So select this one, right click, new view, click OK. So now we are taking only one frame. For this one, we are going to select beam stresses or beam graphs. So for this one, here yes, beam forces, we have that values. Now the value is very small, so we are going to right click, labels, scales. Here we can see the bending moment in z direction. We are going to change this to 10, apply. Yes, now we can see that by changing the value, we are going to get some good bending moment diagram. 12. Yes, we can adjust this one based on our requirement. If I put 7 and apply, it will be more. Yes. So after this one, we need to close this one. Then we'll go back to results, view value, go to the beam result. We are going to click maximum bending moment. Then if you see this annotate, we are going to get a maximum bending moment wherever it is present. We can see that we can change this one to end, then annotate. Then we can change this to any other point, mid point only annotate. So we can see this bending moment diagram. After this one, we'll remove this all, close it. Now what we are going to do is right click, then go to labels, loads and results. We are going to click on shear forces, click on this one, then fill this one, apply. So we can see that this is the shear force diagram. We are unable to see that values. Again go to scale, shear, mm, shear ZZ, shear ZZ. We are going to make it 10. Apply. So shear YY, make it 10. Yes, this is the shear Y direction. So after applying that one, we can click OK. Same way we can go to results, view value, go to the beam result, shear force, maximum value, annotate. After seeing that one, we can remove this. We can see end, annotate. Then midpoint, remove this one. Again annotate. See, we can see the values wherever midpoint shear force, how much it is there. We can see that. And finally, after seeing all this one, we can remove that one. Then finally, we are make it a whole structure. This is the shear force of the whole structure. Then go to, then click this one. Yeah, then right click, then we'll go to beam animation, section displacement, then scale. Here displacement scale should be changed. I'll change to 5. Let's see what will happen. Apply. So animation displacement animation is we say nothing has happened. So reduce to for 10 displacement. Apply that one. Yes, it is vibrating. Displacement you change to 5, then apply. So after this one, click OK. So we can see the displacement for each load combinations. Next, we are going to change for 8. So we want we'll click right click again. Due to the earthquake load, it will vibrate like that. Any load combination, we can check all the load combinations here. The values should be checked for all the load combinations. See here how the building will vibrate. This is the way we are going to get these values. So for each combination, we can check the what is the maximum displacement.